is we're going to solve quadratic systems. You've done systems of equations before. You've done solving systems of linear equations, where you have two equations, two variables. Basically, you're looking at where two lines intersect. You were finding in space where the point at which those two guys would meet. Well, what we're doing today is we're going to take it a step funkier, because that's how we roll. We're going to take a circle and an ellipse. And we're going to figure out where a circle and an ellipse might intersect one another. It does sound like a lot of work, but believe it or not, it's very simple. Okay? Now, just at this quick example here, if I'm looking at this, if I'm looking at the possible ways a circle and an ellipse could intersect, we could intersect how many spots? 4, 2, 3, 1, right? There's 1, 2, 3, 4 possible intersection points here. Do you agree? Yeah. Same idea when you have your lines. Your lines could intersect, oops, that's a parabola. I can intersect this with a parabola and make this really crazy.
So the parabola.
So we can do a lot of craziness here. With lines, you can have one intersection, no intersections, or infinite intersections. Remember that? Yeah, but it wasn't that difficult. You know, it's just substitution and linear combination. So what I want to do here is start with something that is relatively simple. I'm going to start with a circle and a line. I'm going to figure out where a circle and a line intersect. Now think about, we're not graphing this. We're just doing this algebraically. Think about what a circle and a line would look like. Well, a circle and a line.
Sounds like geometry.
It sounds like geometry. Oh, that's a problem. Now, just for argument's sake, I don't know what the equations, I don't know what the answer is going to be here, but in theory, a circle and a line can intersect at how many spots? 2, or 1, or none. Do you agree? So what we're doing here is we're trying to figure out the ordered pair possibilities that they could intersect. Well, you're going to use linear combinations and substitutions like you did back then. Now you just have square terms to worry about. So you've got two equations. X squared plus y squared equals 13, and y equals x plus 1. What are you going to use to solve for one variable? Yes, ma'am?
How are we supposed to know, like, if it's a parabola, or if it's a circle, or if it's a...
In all honesty, it really doesn't matter what you're looking at. You're not really worried about what the graph is. We're going to be able to do this all algebraically. I'm just saying that what it would look like, okay? I'm not requiring that you guys tell me what the shape is, the two shapes are that they're intersecting. We're not plotting them, we're not graphing them, we're just doing the algebra of it, okay? I was just trying to give you a visual of what it would look like. Okay? How would you solve for x here? Give me more louder, please. Substitute in for y, right?
Yeah.
So could I do this and write x squared plus x plus 1 squared is 13? Don't kill a puppy.
I wasn't planning on it.
X squared plus x squared plus 2x plus 1 equals 13. I hope you did not kill a puppy. Now what do you do? Combine like terms and set aside equal to 0, okay? So let's combine like terms. We get 2x squared plus 2x minus 12 is 0. And now I'm down to a factoring problem. And what's your first rule of factoring?
Well, GCF.
What's my GCF?
2.
Factor out of 2. Do the sub sum. Factor out of 2, and I have x squared plus x minus 6 equals 0. What can I do with that 2 now?
Drop it.
Drop it. I can get rid of it. The reason I can get rid of that 2 now is because, see how it's set equal to 0? So if I divide both sides by 2, it just goes away. Because what's 0 divided by 2? 0. So what times what is negative 6 that you add together to get 1?
3 and negative 2.
3 and negative 2, very good. So my terms are x plus 3, x minus 2. If my terms are x plus 3, x minus 2, what are my zeros?
Negative 3 and 2.
Good. -3 and 2. So this tells me right now we've solved for x in this system. This value of x has two possible answers, which means there could be two possible corresponding y values. Does that make sense? So all we have to do now, is I just think I heard you say it, is once you get down to this part here and you have two solutions, whether it's your x value or your y value, what you want to do is start making a tally of your possible solutions. Right now I know that I have a solution for x at -3, comma something, and 2, comma something. You're just falling apart today. Man, you gotta stop skipping school.
I know. I do. Thank you.
Welcome. So, wow. So how do I figure out the corresponding y values if x is, yeah?
Plug it into the.
Are you doing electrical work? Caught her off guard on that one, didn't I?
You put it in the line equation, y equals
What is that called? Thank you! Yeah, just substitute back in, all right? And you're right, you substitute back into the linear equation where y is equal to x plus 1. So if y is x plus 1, what's -3 plus 1? I don't know her name.
-2.
Is it 2 or -2?
-2.
I didn't hear the negative, I just want to make sure you're okay.
Okay.
All right. What's 2 plus 1? 3. And you solve the system of a comic. That's it. Yeah. Like I said, it's not that complicated. The only thing that's different here is that you're winding up with some square terms you're going to have to factor through. What's that?
You just write down the together randomly.
What do you mean randomly?
-3, -2.
Those are my two possible x values.
Yeah.
So this here is my solution set. So all I did is, so I know that I had two possible x values. I know that I'll have two possible y values. So that just means it's intersecting in two spots.
Yeah, but like how do you know that it's -3 and -2? Yeah.
Because I solved for x. What are we asking? How did I get the ordered pair at -3 and
I
-2?
think I just got it, so it's.
What happens here, since I know that x is going to equal -3, the easiest way to figure out what y is, remember how we had two equations? I just substituted in the other equation. If x was -3, then -3 plus 1 gives me my y value.
Wait, but then, what you have to put
You can if you want. That's a, you don't have to. This is another way to tell what I mean.
But like, is.
What's -3 squared? Shh, guys, what's 2 squared?
4.
See how it works?
Yeah.
It's just easier to use this one, that's all.
Oh, so it doesn't matter which one. All right.
It doesn't matter. All we're using this one is because it's easier. Okay? So let's make it funky.
No, how about we don't?
So it takes a second to look at the problems to decide what variable do you want to get by itself to try and solve. If I'm looking at these two different equations, the top equation has x squared and y squared. It's difficult to get x squared and y squared by themselves. Do you agree?
Yeah.
The bottom equation has just x as a single value, but there's also squared terms in there, right? Can I write x is equal to something?
Yeah.
All right, solve that bottom equation for x. What do you get?
X equals 2y squared minus 2.
Are we okay with that?
Yeah.
Okay. What are we going to do? Substitute it. We are not doing electrical work.
Substitute.
Wait, you don't want us to take
You just.
Stay off the NyQuil. Alright. So now you wind up with 2y squared minus 2 is quantity squared plus 4y squared minus 4 is 0. How do you square a square? Well, the same way you would do it before. FOIL it. What's 2y squared times 2y squared? 4y to the 4th. Negative 2 times 2 is positive. Double it, we wind up with negative 8y squared. And what's negative 2 times negative 2?
4.
Your face looked like it just hurt. You all right?
Wait, how'd you get negative 8?
I foiled.
Wait,
You guys, don't you remember the special patterns?
Oh yeah, the point. Oh yeah, it's like
2y times 2y, or, I'm sorry, 2y squared is 4y to the 4th, minus 4y squared minus 4y squared is minus 8y squared plus 4.
I'm not raising my hand.
Square it, both combine together and double it. Just write it out. Okay. So right now you're at something that looks pretty bad, doesn't it? Okay. Combine like terms. You okay with that?
Yep.
Okay. What's your first rule of factoring?
Can't figure out. Dig up the square.
Yeah,
Take out the GCF, right?
4y squared.
Take out a 4y squared, and I'm left with y squared minus 1. Everybody okay with that? Now, does everybody agree that I have two terms now? What do I do with those two terms?
Divide. You have times 0.
Set them both equal to 0. So this first term, you get 4y squared equals 0. That one's easy. What's y going to have to equal here? 0. Y is going to have to equal 0. This second term, can that be factored? Yeah.
That's 1. Right?
1, it's plus or minus 1. If you look at it this way, is y squared a perfect square? Is 1 a perfect square? Is that a subtraction symbol? Therefore, this is the same as y minus 1, y plus 1, which gives you solutions of y equals 1 or y equals negative 1. So in this system, there are 3 possible y solutions, which means how many possible x solutions could we have? 3 of them. So how many times you can substitute in y to get your possible x's?
6 times.
That's it. So you have 3 sets of ordered pairs, one at 0 for y, one at 1 for y, and one at negative 1. And you're right, it can get kind of messy. So we go all the way back up top here. And notice, did we already solve for x with one of them?
Yeah.
We had x was equal to 2y squared minus 2. Wouldn't that be the one I want to substitute in for y?
Yeah.
All right, so let's do that. X is equal to, since we know this from earlier, x was equal to 2y squared minus 2. So if it's 2 times 0 squared minus 2, what do you get? Everybody okay with that? If it's 2 times 1 squared minus 2, what do you get?
-2. 0. I mean, whoops.
Wait, no, yeah, 0.
Oh wait, I was doing -1.
That's okay. And then if it's negative 1, what's 2 times negative 1 squared minus 2?
-2.
What's negative 1 squared?
1.
What's 1 times 2?
2.
What's 2 minus 2?
Wait, it's 0?
So
Dang
if
it!
you have plus or minus, it can be the same.
Not necessarily. Not necessarily. This is an anomaly.
I'm still back.
This is an anomaly.
I thought it
How
was.
should it get to 0?
Oh, because it's -1 squared equals 1.
2 times 1 is 2 squared is 4 minus 2.
No. What's being squared?
1. -1.
The 1 is being squared. It's just the 1 that's being squared, not the 2 times 1 being squared. All right? Yes, ma'am.
How come you didn't drop this, like, stuff out, so I go to the Like you dropped it to
Because the other one had, the 2 was just a constant. It had variables, yeah, can't drop that.
Okay.
Okay. And that's your 3 possible ways that these intersect. Yeah.
Wait, so like, what would be intersecting?
Guys,
What would be intersecting?
what are the 2 shapes? I think this one is no, this is an ellipse and a parabola. This is the intersection of an ellipse and a parabola. Which makes sense, if you have an ellipse and a parabola, could it possibly intersect at 3 spots? Yeah. One of them's on the parabola, or where they are both resting on one another, and then just the other 2 tails. It's completely plausible. I don't care what it looks like. I'm not trying to graph it. No need to. I'm just doing the algebra of it. Okay. Do you see how it is very similar to what you guys did with linear combinations a year or so ago? Just throwing the quadratics up to it. Okay. Take a look at this method. Sometimes they're easier than others. Sometimes they're an extra step than others. What is this one? I think this one's easy. No, honestly, I think this is the easier of the methods. A little take on what you guys did back with linear combinations. Remember, if you had the same sign with the same coefficient, you would subtract them to eliminate? Or if you had the same coefficient with opposite signs, you'd add them together to eliminate a variable? It's the same basic principle. I'm just adding one part to it. Same coefficient with the same exponent. Notice here in this problem we have x squared plus y squared, and then the bottom one it's x squared minus y squared. Is there in any one of these either equations a standalone y? So if I want to eliminate the y squareds, I would just subtract those 2 equations together. That would eliminate y squared. Do you agree?
Yeah.
Let's do that. So I'm going to subtract these 2 guys, or excuse me, I'm going to add them together. In adding these together, I'm kind of rewrite this a little bit here. I have, I'll just do it this way. If I add, it was x squared minus y squared, and it was what, minus 9?
Yes.
Okay. What I'm doing here is just grouping them together. Everybody okay with that? I just kind of line them up alongside one another. When I add them together, I'm going to get the following. 2x squared minus 16x plus 30 equals 0. Did I solve for x without too much of a hassle? What's my first rule? What's my GC up here, ladies and gentlemen?
2.
Take out the 2, and I get x squared minus 8x plus 15 is 0. Now, Maddie, can I get rid of my 2 here?
Yeah.
I can, and why can I get rid of my 2? There's no variable there. Everybody okay with that? The 2 can go away because I have set equal to 0. So what are my 2 terms going to be here? Negative 5, negative 3. The zeros are 5 and 3. Very good. So my terms, x minus 5, x minus 3, give me zeros of 5 and 3, which means my x coordinates for the possible solutions are going to be 5 and 3. So I have a 5 comma something and a 3 comma something, which means all I have to do now is go back and figure out what y is going to equal. All right? Are we okay with that? All right. Now, if we go back to this secondary equation, x squared minus y squared minus 9, that was the one that equaled 0, right? Okay. So we had x squared minus y squared minus 9 equals 0. In order for us to figure out what the y value is going to wind up being here, I'm going to get y by itself, right? How do I do that? Add y squared, okay. Yeah, Izzy?
Can you square root the whole thing since you can
Well, here's what happens. What happens if you take the square root? Plus or minus. You have a plus or minus here. So it's going to be the plus or minus square root of x squared minus 9 will give us our y value.
Right?
If I take the square root there? Yeah.
Just put x plus or minus 3. Or does that all have to be into the root, like plus or minus?
You want to do it all under the root, because you take the plus or minus of that root. Okay. So now all I have to do is just substitute in twice. What's 5 squared?
25,
So I have plus or minus the square root of 25 minus 9, which is
16,
16, so it's plus or minus 4. So it's 5 plus or minus 4, which means it's at 5 comma 4 and 5 comma negative 4. Okay with that? That's all that's saying. This is really two ordered pairs, it's these two. All right, we just simplified it out. When I substitute in 3, you get plus or minus, what's 3 squared?
9,
What's 9 minus 9?
0,
So it's just at 3 and 0. So this intersects at how many possible spots?
3.
3. Yes, ma'am.
So instead of getting the y alone, I just plugged the x back in the equation, but I still got all the same answers. So can I do that?
That's
Do I have to
fine.
get-
There's a couple of ways of doing it. It's fine. I went to this one because I knew that I could get y by itself quicker. That's all.
Okay.
And please join the Electrical Brotherhood of the Brotherhood of Electric, IBEW, whatever it is. Because this whole plugging it in thing is really getting, you know. I'm just gonna, you know what? I think I have a cord. I can just walk around.
She's in a cord.
That's not.
Next time you want to plug something in, you go plug that in. Thanks. I have props. Yay. Now, guys, like I said, the worst thing of this stuff is when you go to substitute back in, it's just to watch your plus minuses. Because a lot of times when you're taking square roots, you can have a plus or a minus value thrown in here. So this actually has 3 total solutions. These 2 and that one. Okay. Let me give you a few of these. Yes, ma'am.
Would we be wrong if we wrote what she wrote in red, like?
Do the 5 plus or minus 4?
Yeah.
No, I wouldn't be wrong. I was just showing you what that meant. That's all. I'm not going to yell at you if you do that. Because every once in a while, it does work like that. And all you're doing is just saving pencil lead.
It's not right.
What did I give you? 7 of them?
7, yeah.
Oh, that's more than we usually have, that's too much.
Hey, you're lucky I didn't give you the 3 variable ones.
That sounds fun.
It's actually not that bad. It's just a lot of substitution. To be honest with you, one of the downfalls of how we've gone about pacing through some of this stuff this year is that we did not do anything with matrices. And within matrices, you can solve systems of equations that have, 4 variables and 4 equations by pressing a couple of buttons on your calculator. But it doesn't work for quadratics. Okay? Give those a shot. We'll check them through tomorrow. Yes, ma'am.
Can you do that thing in the calculator?
I can't because I don't have an Inspire, the Inspire one that has that built into it. I have to have an Inspire calculator with that app on there in order to make it work, and I don't have the Inspire that has. I have to ask to see if Fontana has one. Yes, ma'am. No, I think I did like the majority of it, except for the graphic.
Wait, for graphing these?
No, you're not graphing this.